Yes? Anything that's on that calendar, you can do it.
Oh, I'm sorry for that. I'm Saturday.
So, let's move forward. We're in Unit 2. And I'm not going to lie. Might be one of the hardest tests you take this year. Next Thursday.
Next Thursday?
Because it deals with something that everybody struggles with, which is rational operations. Adding, subtracting fractions. If I give you something like this, 1 over 2 plus 2 plus 3, you cannot just add the top, right? 3 and then add the bottom 5. It doesn't work like that, does it? What you need to do first is what with fractions?
Find the common.
Very good. Find the least common denominator. So what does 2 and 3 have in common? What can they both be divisible into? 6. Again, just multiply the 2. That's pretty much the easiest way. 2 times 3 is 6. So I want the denominator, the bottom, to both be 6. So what changes do I need to make? 2 times what is 6?
3.
2 times 3. So again, if I change the bottom, I also have to change the top by multiplying that by 3. Gives me a 3. And 3 times what is 6? 2. Which I need to also multiply the top by 2. That gives me a 4. And then now I can add the fractions together. 3 plus 4 is 7. Does this become a 12?
No.
It says 6.
Stays as a 6.
Let me write that down.
So 7, 6.
So I don't forget that. I'm going to get that drilled in my head. Good.
So note, we're kind of not done here. Our final step needs to be to simplify this fraction. Does it simplify?
Wait, what?
Does this fraction simplify?
No, you can't
No.
bring it down no more.
So we're done. Now again, like I've mentioned earlier,
You can bring it down, right?
like I mentioned earlier, you can use your calculator to help you simplify. So this was 1 over 2. 1 over 2 plus 2/3 gives me that. Let me turn that into a fraction. So math, fraction, enter. 7/6. The calculator will give you your most simplified version of the fraction. So it is simplified. Now, we're about to introduce, because that's all middle school, we're about to introduce some variables into this. Please note, you cannot put variables or divide variables in a calculator. I'm going to see many students do this, unfortunately, because they're just going to be completely lost and figured I'll just go put it in my calculator and see what happens. 8 over 2x plus 2 over 3x gives you this, a number, which does not make any sense whatsoever. What the calculator does is, it doesn't know what x is, so it's going to input whatever value for x is. The default is usually 10, but I've seen some calculators have a different number here. And then it's just going to do that calculation. So instead of giving me an error message, it's going to give you this. And you can go like, hey, I didn't get an error, so maybe that's what the answer is. Please don't do this. It only works with numbers, not variables. So how do you work with variables, with rational functions, adding or subtracting? Well, we're going to follow the same steps as if they were numbers. We're going to find the least common denominator.
Or like a GCF.
It's going to work very similar to the GCF. If they're not the same denominator, then we need to set the fractions to that LCD. Next, once we're there, then we can start adding or subtracting. Please note, and I'll explain this later, we will not be subtracting. We're only going to add and multiply in this class, and I'll explain to you why. And then simplify. Always simplify last with fractions. So here's my first example. This should be more algebra 2. 2 over 3x plus 5 over 2x. Do they have the same denominator? No. 3x and 2x are different, right? Different numbers. Which means I need to have them equal the same denominator. We already saw that 3 and 2 have an LCD of 6, but what about x? Would it be x squared? No, just like with the GCF, greatest common factor, you're going to take the lowest exponent. So in this case, they have an x in common. Let's say I want to change this to x squared and 3. What would be my LCD? 6x. No, not 6.
5?
No. Remember, if this was GCF, what would you take out?
Wait, was he?
If this was a GCF, what's the common between x squared and x3? x6 squared, the smallest one. You're always going to take, the LCD is always going to be the smallest, the least common denominator. So let me change this to a 12 and this to a 23. What is my LCD? 6x? 12. If I change this to a 212 and a 123, what's my GCF? 123. The smallest one. Your least common. So there's how you deal with the exponents. So LCD is 6x. I need to change 3x and 2x to that 6x. To get there, 2x needs to be multiplied by 3. So 2x times 3, again, need to multiply the top by that 3, 15. This other one, 3x to 6x, multiply that by 2. 3x times 2, I need to multiply the top by 2. 2 times 2 is 4. Now I get this, 4 over 6x plus 15 over 6x. Are they the same denominator? They are, so I can go on to step 2, which is go ahead and add them. Again, you're only going to add the numerators. So what is 4 plus 15? 19. The denominator stays the same, 6x. What was that final step?
Simplify.
Simplify. Can I simplify this?
No.
Well, you could try. Say you want to lean on the calculator. So let me.
19 can be factored.
Oh, yeah, you get it.
Well, I could try. Let's see. 19 over, what was it, 6?
Could you just simplify the top, or no, you can't?
No. It's 19 over 6 stays the same.
I would probably did that and failed, but not.
No, that's fine.
I know.
I would have given you some credit there. You would have got most of the way through. So yes, this is already simplified and we're done. So again, with the exponents, we're going to take the smallest one, or with variables, sorry. With the numbers, it's going to work the same as they always have. And yeah, there we go. Here's what college algebra is going to kind of look like in this class. I want to add these two fractions together. X plus 2 over 2x squared plus 13x plus 20. I'm subtracting that from x plus 3 over 2x squared plus 13x plus 20. And why do we deal with factoring the first 2 weeks of school? Well, here's where it comes up. This is one of those rare moments where it actually comes back in college algebra. You should already see 2x squared plus 13x plus 20 and think, oh, maybe I could factor that. Because let's just say hypothetically that factors into x plus 5 times x plus 2. What happens with the x plus 2's? On the top and the bottom.
They cross out.
Yeah, they reduce to 1. You could do something like that. So factoring is a good thing to do first because it could make your life simpler. For the sake of time, I'm going to go ahead and factor that for you. They factor into 2x plus 5 times x plus 4. Now step 1, do they have the same denominator? They do, right? So we don't have to worry about step 1 setting it to the same denominator. We're lucky enough that they're already there. Which means now I can do my operation. So here's our LCD. Notice I'm taking each of these terms, 2x plus 5 and x plus 4.
What was that test called we just took?
Factoring,
Factoring test. I need retake.
or just test 2.
Okay.
Now, remember I said we're not going to deal with subtraction, only addition? Here's why. I want you to change every time you see subtraction, change it to an addition problem. So that is now a plus. And how can I change this to a plus? Well, I multiply that negative by a negative 1. Now remember, if you change something in the denominator, you also change the numerator. Likewise, if I change this, something else needs to change. And that changes, so this is step 1, that change happens here. Notice that subtraction sign was attached to this fraction. I need to multiply the top, the numerator, by a negative 1. So bear with me. So what happens if I multiply the top by a negative 1? And I distribute? This becomes a what? Negative? Negative x. And then negative 1 times 3 is a? Minus 3. So what really happened on the second step is that I started with x plus 3, and now I have negative x minus 3. I did what? I flipped the signs. Yep. So, if you see subtraction, change it to an addition problem, flip the signs on the second one, the one on the right, the one it's attached to Do you flip this? No. Do you see a negative out here? No, it's a plus, so that stays the same. I see a negative, so I'm changing that to a plus, so all these get flipped. Plus x becomes negative x, plus 3 becomes a negative 3. And it kind of works like this. So it's a little misleading, that subtraction sign. You can't just do this by taking x plus 2, x plus 3, and then slap a subtraction in between the two. Doesn't work when these are actually bounded by that operation. Because what normally happens, what I'm going to see most often, is this x, with these x's will cancel, and you have 2 minus 3, negative 1. Or sorry, I just did that the right way in my head. If you would have bound these together, students would write this on their paper. These x's would cancel, and then add the 2 and the 3, and you get 5. Unfortunately, that's not how it should be done. Again, change it to addition. Step 1. Step 2, flip the signs. So you got a little bit extra steps to do at the beginning with subtraction.
So the first step was multiply.
Yeah, you're kind of multiplying the subtraction by a negative 1. So you then also you have to multiply this. That's what the algebra is going on. But just change it to addition, flip all the signs on the right. Now it's an addition problem. Now that I've done that, I can bring the problem together as one fraction since they have the same LCD. And then I can combine like terms. So x minus x cancels. 2 minus 3 is a negative 1. That's all over 2x plus 5 over x plus 4. Nothing to simplify, so then this will be your final answer.
A big old thing right there.
This big old thing right there, yep.
What?
That's what your answer is going to look like.
I thought it was hard. The other one's like 2 numbers. One at the top, one at the
So
bottom.
the 2 and the 3 you were subtracting?
Yeah, so we're basically, at this point, we're combining like terms and numerators. X's, we're going to add those together. They cancel, and then the constants, 2 and a negative 3, gives me a negative 1.
Man, I'm glad you're making videos about kids. I gotta go over.
Now notice, I kind of already gave you the factors, x plus 5, x plus 4. If they happen to be like this, these are two different numbers, right? X plus 7, x minus 8. I can't go and say the LCD is an x and a negative 48 or negative 56. I can't go and say an x squared because, again, these are bounded by the operation first. We have to do this before we can recognize them as a single number because that's what they are. Which means my LCD, what do you think it's going to be?
X,
Well, let's start small again. 2 and 3. What was that LCD? 6. How did you get there?
because you multiply.
Multiply.
Oh,
So
seven.
multiply, what happens when you multiply x plus 7 times x minus 8? You get x plus 7 times x minus 8. That is what's going
The
to...
same thing?
Yeah, same thing. That's your LCD. Just multiply them together. Now you can't bring them together yet.
So you just put parentheses.
And that's the
You're
answer?
multiplying.
That's the LCD, yes. Yeah, you just multiply the numerators to get your LCD, right? And the denominators. You see it? Just treat them as one term. They come down here. Because I can't treat them separate. Because I have to do this operation first. Whatever it is. Now we have to set them equal to x plus 7 times x minus 8. This has x plus 7, but it's missing this part. So I need to multiply this bottom by x minus 8, which means I need to multiply the top by x minus 8. This one has the x minus 8, but it's missing the x plus 7. So I have to multiply the top and the bottom by that
So
x
it's
plus
not
7.
reverse.
Yeah, it's kind of a cross multiply really works with the equal sign, but it does work here. If
So
the
you
numbers,
just- So this goes that way and this goes.
And you can multiply
Yes.
them in a calculator like that, right? Right now.
no, remember the variables. You can't do that with the variables.
So yeah.
So you multiply -8 with 7. Or you should.
This is what it looks like together. right? Here's my LCD, x minus 8, x plus 7, x minus 8, x plus 7. I need to multiply this side by an x minus 8, this side by the x plus 7. Now, if you just saw 3 times x minus 8, what would you do?
3 times x minus 8. I would do 3 times 1, 3 times x, and then.
What's that called? Starts with a D.
Starts with E.
D.
D. A D. What?
Rhymes with review.
Distribute.
Distribute. So 3 times x and 3 times negative 8, right? 4 times x, 4 times 7. Yes. So you would distribute. That gives you 3x minus 24 and 4x plus 28. Do I need to do anything with the sign?
Go back to the question we was on. Go back.
Yeah.
Go back again.
Go back again. Okay.
Okay, that's when you got that 3 and the 4 from. Okay, I see.
Yeah, it's part of the original problem.
So you just put it at the front and you distributed them.
Now that we have them set to the LCD, we distributed. They're good to combine like terms. Let's bring them all together, like so. So all one fraction. 3x plus 4x gives me 7x. And negative 24 plus 28 gives me a plus 4. All over x plus 7 times x minus 8. Our last step with fractions is to do what?
Simplify.
Simplify. Is there anything to distribute out between 7x and 4?
7 and 4, no.
No. So, and there's not another 7x plus 4 on the bottom, so there's nothing to simplify.
That's your answer.
So that's my answer. Yes.
It's a lot of stuff for this because it's a little bit
Yeah, it's a lot of steps to make mistakes. That's the toughest part. It also requires a lot of practice to get there. Speaking of practice, let's go. Yeah, so my LCD is n plus 8 times n plus 1. That's what both of these fractions are going to be. That's my goal.
That's the denominator?
That's going to be the denominator
For the
bottom part.
for the bottom part. How do I get here from this fraction? 2 over n plus 8.
Plus 8 plus 8.
So it's going to be a 2 where I have my n plus 8. Which part am I missing from the LCD? The n plus 1. So again, I'm multiplying this bottom by the n plus 1. I must multiply the top by n plus 1. And then over here, what am I multiplying with the 4? N plus 8, because this n plus 1 is missing that part of my LCD. And I must also multiply the top.
That's all steps on this.
Now, kind of hard for us to add this together and combine like terms when we're not exactly done yet. We have to follow our order of operations. Have to do the parentheses and multiplication first before we add. With this multiplication, I'll need to what? Distribute. So that gives me a 2n plus 1. Oh, sorry, it's plus 2. And then here, also distribute. That's a 4n plus 32. All over my LCD. Last but not least, when you combine it, what?
So you would put the 2n plus 2 and then the 4n plus 32 together?
Yes. So what's next? What happens when you have the n, when you add the n's together?
You can put them in a calculator, so
6n
yeah.
plus 32 plus 2, 34, all over n plus 8,
N plus 1.
n plus 1. I could think about factoring out a 2, perhaps. Let's see just what happens. So let me take out a 2. That's 3n plus 17, which has nothing in common with anything on the bottom, right? So I would be okay to leave it like so. Now, how does adding a subtraction changed this problem. What was the first thing I told you to do?
You multiply the minus to the
So this turns into
Positive.
positive, or in this case, an addition problem. That's step one. What's another change? You make one change, you have to make something else.
The
Add what to the 4?
The minus.
A negative. So I'm changing all the signs on the right. So that becomes a negative 4. So it's a plus. That's a negative. Which changes everything up over here. So that's still a 2n plus 2. But now this is a negative 4. So that's a negative 4n. And negative 4 times 8, a negative 32. All over my LCD. So now when I combine like terms, I get a negative 2n minus 30. All over n plus 8, n plus 1. Which of course, again, you could factor out a negative 2, just to be nice, neat, and clean. It's a plus 15, which does not simplify to anything on the bottom, so you're okay there. So let's see, did you get 6n plus 34 here? Hopefully. You got close. Did you at least get the LCD?
Oh, yeah.
Did we get a negative 2n minus 30 here?
Here.
This is not fair.
So give yourself a pat on the back if you got the subtraction one.